All right, section 2 of chapter 2, we're going to get into a special type of distribution in what's known as a normal distribution. Okay, three things that have to happen for me to get a normal distribution is number one, we have to have a symmetry, we want bell-shaped, and we want a single peak. Okay, a lot of times people will mention normal distribution, they'll talk about that bell-shaped curve, and it's going to look something like this. Okay. It's very common in a lot of situations that we'll run into a normal distributions, and what happens, and then we'll see as we go along, is that certain proportions fall below certain values. Okay. So one of those rules is what we call the 68, 95, 99.7 rule. It's also called the empirical rule. It's just kind of a shortcut once in a while. The 68 is talking about 68% of the observations are within one standard deviation of my mean. Okay. And so once I calculate out my mean, okay, I'm going to say it's 0 here, and we'll talk about that y in a second. I'm going to go one standard deviation below. So whatever the standard deviation is, I'm going to subtract it from my mean, and then I'm going to add it to my mean to get to 1 below. So 68% falls in that area. Now, because, go back and talked about symmetry, okay, what that's going to do is break it up into halves, 34 and 34. 95% of my observations are going to be within 2 standard deviations. Okay, so that's talking from here to here now. Okay, and we talk about how I've already used up the 68, which leaves me with 27. So if I cut that in half, that's where I'm getting my 13.5 and my 13.5. 99.7 is within 3 standard deviations. Okay, so again, same idea, 99.7, I've already used up 95, so I got 4.7, which I divide by 2, and that's where my 2.35 is coming from. And then finally, you have 100% is all my observations. Take away the 99.7, you get your 0.3 divided by 2, and that's where the 0.15 are outside of 3 standard deviations. Very few observations outside of 3 standard deviations in a normal distribution. Now, this can be helpful once in a while, and we'll get more into it when we start talking about confidence intervals later in the year. Okay, and we'll use this to go through a few situations so you kind of get a little better understanding of the normal distributions, but eventually we'll just use z-scores all the time. Okay. All right, so the reason we want 0, 1, 2, and 3 and use my mean as zeros, because that's what we do when we take our standard normal distribution. We standardize it, okay, in terms of some number of standard deviations again. Okay, so we're going to do my z-scores, but now my observation again minus my mean. Okay, this again is mu, which is the mean of my population. Okay, so I'm going to look to see how far we are away. Now, how this whole thing works is that I'm going to calculate that out. And a couple things we're always going to talk about with my distribution is always draw a picture, because anything that's less than my mean, okay, if I'm taking my observation minus my mean, number smaller than the mean, small minus big will give me a negative value. Okay, so anything below the mean should be negative, anything above the mean should be positive. It's very common that people switch the mean and the observation around, so a picture is always going to help us. But then we'll divide that value by my standard deviation. It's going to give me some z-score. Now, with my z-scores, I always want to go at least 2 decimal places. Okay, so I'm going to have some number, and I want to go 2 decimal places, so I'm going to round. So again, you got to go that third and see if it's 4 or less, we'll leave it. If it's 5 or more, we'll round it up. Okay, but we want to go those 2 decimal places, because then again, this first decimal is going to be, or these 2 parts here are going to be down this column, and then this hundredths digit is somewhere in there, and we're looking for where they meet. Now, one of the biggest things to remember again is the probability, okay, that a value is below that observation or my z-score that I get. So a couple things to remember, and we'll talk about this more as we look at a few examples, but if they're looking for this area down here, it's just going to be the number for your table. I'm just going to use it as P right now. Okay, you're going to have some situations though when you look for that area. And because when you look up your z-score, it tells you this p-value below. What I want is what's up here, so we're going to subtract it from 1. And then the other situation is from time to time, you look for an area between two p-values. Okay, so this would be the smaller of the two p-values. This would be the bigger of the two p-values. And so what we're going to do to find this region is take that big p-value minus the small one. Okay, just kind of a guide to help you with that. They may ask you to determine if a distribution is normal, and the other thing we may want to look to see if a distribution is normal is because if it is, then I can use the z-scores, use that table. Okay, so if I was going to do this by hand, I would have to first plot my data, okay, and ask myself, does it look symmetric? Does it look like a bell? Okay, and does it have a single peak? Okay. If that falls true, or if that part's true, then what I have to do is calculate my mean and standard deviation, and then set up my number line, and put those points, 1, 2, 3, standard deviations above and below, and see how many observations fall in each of those areas, and see if the 68, 95, 99.7 holds. Or what I can do with my calculator is use what's called the normal probability plot. Okay, so again, to get to your plots, it's second y equals, okay, and it's your last option down here for your type is your normal probability plot. Okay, this is where you have your data stored. Just make sure this is always x because we're going to go along the x-axis. Now, what I'm looking for is if my data is close to linear. Okay. So if I could draw a line, and almost like our linear regression that you've done somewhere else before, then we have a situation where we can consider it as a normal distribution. Okay. So, and what you're going to find out is as we go on, these normal probabilities are going to be very common in a lot of different things that we do. When we get later in the year, when we deal with proportions in our inference idea, we'll be using these z-scores again.